Good evening, children. Today we are going to see the concept of quantization of angular momentum under de Broglie's theory. Quantization of, that is in atomic structure. Think about electron to be existing in a phase. Electron to be exist in phase. So we can calculate the circumference of electrons. The circumference of the orbit is equal to orbit. This is an orbit. Circumference of the orbit is equal to n lambda. You know the point. So already we have studied in Bohr concept, 2 pi r is equal to n lambda. This is the definition. There is a circumference of the circular orbit is that equal to the integral multiple of a wavelength. Is that equal to integral multiple of a wavelength. Lambda is equal to wavelength. Lambda is equal to that wavelength. So from this concept, that the concept of lambda, now we can go for, that is 2 pi r is equal to n lambda. There is a lambda is equal to, we have derived already, there is lambda is equal to, there is h by, there is mv. Now you substitute this value, 2 pi r is equal to n into, there is a point you write h by mv. There is a point you write mv, you take it now. mv r is equal to, that is n into h by 2 pi. This is nothing but we can say, or this is nothing but we can say angular momentum of the particles. Or of the electrons, not the, of the electrons. Angular momentum of the electrons. Now in this case, we have to calculate this. This is that we have derived from this Bohr's concept. And Bohr's concept and as well as de Broglie concept. Or having agreement with that de Broglie and also that Bohr concept is having agreement with that each other. Why? Because mr is nothing but there is angular momentum that is equal to n into h by 2 pi. The n is equal to principal quantum number. That is n is equal to 1, 2, 3, 4. This is the values. The n denotes there is a first orbit. N denotes this is a nucleus. There is a first orbit. N is equal to 2, this is a nucleus, N is equal to 1, this is N is equal to 1, and here N is equal to 2. And here there is N is equal to 3, this is the nucleus, this is the nucleus, and here that first shell, and second shell, and third shell. This is that we can say K, L, M, N. That is the point you can write. N is equal to 1, N is equal to 2, N is equal to 3. This is the point you should understand here. Next you can go for n is equal to 4, that means, and here the positive charge, second cell, third cell and fourth cell. That you can write here, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. This is the point. Now this is that, it is a nucleus, which is to be the center of the atoms, which is a nucleus, which is to be the center of the atoms. There should be any electrons which are revolving around the nucleus. There should be any electrons which are revolving around the nucleus. That is that, there is an electron which are present in the phase. This is the point you should, it is existing in the phase. Now in these cases, and which are all to be that allowed state for this electrons and its allowed state, allowed methods of electrons. Now we can go for, this is nucleus, this is the first shell, which is to be that waveform of an electrons, waveforms. There we can see there is a principal quantum number 1, that is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Now in these cases, we can understand the point, what is that, the electrons wave, which used to be in the form of wave natures, that is n is equal to 3. Now you see there is n is equal to 4. Now you see there is n is equal to 5. Now you see there is n is equal to 6. That is that electrons which are to be in this wave form, and this wave nature is to be very predominantly explained by there is a scientist whose name was Davison and Zerber experiment, which is very clearly explained this wave nature of electrons. What it stated, we should understand there is a theoretical point which is given in our book. Just I am giving that a rough diagrammatic representation about that experiment. In that experiment, which containing electric gun and which is emitting electrons, there is an emission of electrons. Emission of electrons. That is electron. That is a beam of electrons, we can say. Beam of electrons. Electron beam, there is an electrons which are to be emitted, and these all emitted electrons are accelerated by the battery. So here, which is provided by the battery, which are to be accelerated with a high speed, and which also consist of evacuated chambers. These evacuated chambers which are to be having free movement of electrons, which are provided here, and free movement of electrons. Now here, which is provided with that nickel, there is a nickel, the nickel target, which is used to have to detect the beam of electrons which are rotate in a circular motions. Actually, while we are pausing, just there is an electron which are incident on the surface of nickel. That incident electron is reflected, and here it is reflected, and these reflected electrons all to be, this is reflected rays, to be identified by using, there is a detector. This detector which give very clear information about that this all the beam of electron which is deflected and reflected, and this all get to be scattered. This scattered electron all to be rotates in a circular motions or circular path. There should be a wave nature of an electrons. So now this is that experiment which explains this wave nature of an electrons. And here the next things what we want to see about here, if it is that electron to be in wave natures, and we cannot explain the concept of and its free motions, and which is to be that electron is very microscopic particles. In that microscopic particles and its movements and its rotations we cannot calculate, and that is why there is a new concept which is to be developed. And that is what we can say Heisenberg uncertainty principle. That is what is the next concept. Heisenberg uncertainty principle is very clearly explained. The electron which are to be that microscopic particles which are diffracted, and these diffracted rays only we can see in these cases of the diffracted rays, and here which are to be seen in this screen. And here it is that electrons which are spread over this entire screen, and from these observations we should understand there is a wave nature of electrons. Next concept, if it is that electron is microscopic particles, how these motions are takes place. Just we are going to understand about this, what is that movement of electrons. And actually if there is an electron which are moving in a circular path, the electrons which are moving in a circular path, actually we want to identify the positions and momentum. We can calculate this position of that electron, and also we can calculate this momentum of the electron. Is it possible? Actually, according to the concept of there is Heisenberg, it is impossible to how to calculate this uncertainty of there is to be the position and momentum of that particles. There is a limitations. That means limitation means, and here it is the microscopic particles and very minute submicroscopic particles, and its positions and its momentum is we cannot calculate in a circular path. Where it is in macroscopic particles like aeroplane, or it is to be any object which is revolving around the circular path, we can calculate its positions and also its momentum. It is possible. But in this case of electron-like particles, subatomic particle and submicroscopic particles,
We cannot accurately calculate the position and momentum. That is the statement which was given by Heisenberg. It is known as Heisenberg uncertainty principle.
Uncertainty principle. What is stated? It is impossible to measure the position and momentum of the microscopic particles. Microscopic particles, that is, it is impossible to measure this position and momentum of the submicroscopic particles at simultaneous process. Simultaneously, that is the statement which was given by Heisenberg. Now he has given that one relationship, that is delta x into delta v greater than or equal to, that is h by 4 pi. This is a point you should understand. This explains these positions. This explains this momentum of the electrons. Now you take it, this is that circular path. It is positive nucleus. It is a nucleus. It is to be the circular path, and it is to be the circular path, electrons which are revolving, and here the positions, and here it is the momentums, and it is the positions. It is not possible, not at all possible, not possible to calculate, to measure. This is a statement which was given by this Heisenberg. This is delta x denotes position of the electrons. Momentum is nothing but there is a p momentum is nothing but against the momentum of the electrons. That you know, delta p is we can written as m into delta v. This is velocity of electron. This is velocity of electron. Now you related this concept. What is here? There is delta x into, there is m into delta v is equal to h by 4 pi. You suppose we want to calculate velocity. Now velocity is equal to h, there is velocity is equal to velocity h by delta x into m into 4 pi. You supposed to want to calculate positions. Delta s is equal to delta x is equal to, you can write h by, there is a point you write here, m into delta v into 4 pi. You know that pi is equal to 3.14. And here the mass is nothing but, there is a mass of electron. Mass of electrons. Velocity is nothing but, there is a velocity of light. There is a h is nothing but, it is a Planck constant. Planck constant. That is equal to 6.626 into 10 power minus 34 kilogram meter square second inverse. This is a point you should understand. Now we can calculate the position of electrons. Now we can calculate this velocity of electrons. Now we can calculate this mass of electrons by using this Heisenberg uncertainty principle. Now see, you have to calculate the velocity. The Planck constant value, you know that 6.626 in 10 power minus 34 kilogram meter square second inverse, the formula. Now you write, there is a formula which is given is 4, pi value is 3.14, and electron mass is a very familiar, you know that mass of electron, that is 9.1 into 10 power minus 31 kilograms. Now you write this, what is that?
Here what is given? Position. The position is nothing but we can write 2.645 to 10 power minus 13 meters. Now you see here the meter and meter cancel, unit cancellations. Now the point you should understand. Kilogram cancel. And this all you have to consolidate, and finally you will calculate this velocity. That is velocity is equal to, that is in values. That is meter per second is a unit. And what is the value which is given is 2.189, that is meter per second is the velocity of the electrons, which we can calculate by using this Heisenberg uncertainty principle. Next we are going to see the quantum mechanical model of Schrodinger wave equations. What is this? You should understand. So this explains this, the motion of objects, any object and its moments, we can calculate. The motion of objects very clearly explained by these Newton's motion of law or law of motions. And here by using Newton's law of motion we can calculate the position and momentum of the particles. It is possible by physical methods that you know. And here that Heisenberg also cannot explain how to measure this position and momentum of the particles simultaneously. And here the classical mechanical theories, that is classical mechanics does not explain this position of the particles. The new mechanics which was introduced by this Erwin Schrodinger to explain this wave nature by using the differential equations. And here these equations determine the change of wave functions in a space which depending upon this is a nucleus, there it should be an electrons which are revolving around this, electrons which are revolving around. In its own path is called, we can say, circular orbit. Now you should understand about the point what is here. This is to be, and here you can take it as it is y-axis, this is to be that x-axis, this is to be the z-axis coordinates. Now we can calculate this position of electrons. What is the position? So this is also that axis, that you know, z-axis. Now this position is also to be calculated. And here there is to be the space around the nucleus, which on the field of force which is existing, which is the electron which are moving around the nucleus. There we cannot find the time which is to be that electron which is moving in this space, moving in this circular path. There is a time independent Schrodinger wave equations which was derived by the Schrodinger, and he has given one equations, that is a H cap psi is equal to E psi. The psi which explain these wave functions, that's all. The psi values which explain these wave functions. The H value which is derived value, that is H is equal to, there is a derived values of H square divided by 8 pi square m into, there is del square by del x square plus del square by del y square plus del square by del z square plus there is v. This is a value which is derived values, and this you have to substitute, this H value you have to substitute in these main equations, that you know H cap psi is equal to, that is E psi. Now what is the value of H? You have to substitute this value. You see here, there is that point you should understand here in this equation, that is Schrodinger wave equations, and here this is the point you should understand here. This all you write here, that is the value you can write minus H square divided by 8 pi square m, that is into del, you see that value, del square psi divided by, and here del x square plus del square psi divided by del y square, that is plus del square psi divided by del z square, that is plus v psi. This differential equation is minus h square divided by 8 pi square. This is a point you should write. 8 pi square into m into differential equation of del square psi divided by del x square plus del square psi divided by del y square, that is plus del square psi by del z square plus v, that is psi, that is equal to E sine. Now this entire equations to be multiplied by this entire equation is multiplied. This entire equation is multiplied by, that is minus 8 pi square m divided by h square. Now you substitute this value and you have to multiply this. You have to multiply this. Finally, you will get that values. What is that? What is the value? That is the point you should understand. Minus h square divided by 8 pi square m into del square psi divided by del x square plus del square psi divided by del y square plus del square psi divided by del x z square plus v into psi. The v is nothing but there is that potential energy of an electrons, that is multiplied with minus 8 pi square m divided by h square. Finally, you will rearrange these equations. You will get that equations, that is del square psi divided by del x square plus del square psi divided by del y square plus del square psi divided by del z square, that is plus 8 pi square m divided by h square, that is into, that is E minus V into psi, that is whole is equal to 0. And here this is that the values are permitted total energy of an electrons. This is permitted total energy of electron in atomic orbitals. Atomic orbitals. And you know the points here. E is nothing but there is a total energy of the electrons. V is nothing but potential energy. K is nothing but kinetic energy. And here this is that permitted total energy. Only we can see that is energy of an electrons. This is time independent. There is no mentioned time intervals. So it is time independent Schrodinger equations. Time independent Schrodinger wave equations. This is time independent Schrodinger wave equations. The next, by using these all concept, the next session we are going to study about these quantum numbers and all. This is a concept you should understand. This equation is nothing but there is a time independent Schrodinger equations, that is h cap psi is equal to E psi. This psi is wave functions. H is equal to Hamiltonian's operators. That it is explained these wave functions of these all electrons which are present and revolving around the nucleus. There is h value is equal to, this is minus h square divided by 8 pi square m into del square divided by del x square plus del square divided by del y square plus del square divided by del z square plus v. This is that h cap psi is equal to E psi, and here this is that we have to substitute these values h value into these main equations, and finally you will get these equations, and these equations is multiplied by these equations, that is minus 8 pi square divided by m pi square m divided by h square, and finally you will get these rearranged equations. These rearranged equations is only for this permitted total energy of electron in atomic orbitals. This is a concept. We are going to see the next session. That is that what are the quantum numbers. That's thank you. You please have to concentrate more about that your studies, and you please do this many times. Finally, you will get that idea about what is quantization, what is de Broglie's concept, what is Heisenberg uncertainty principle, what is Davison-Zermer experiment, and what is Schrodinger wave equations. Thank you.